Okay. Good morning. I'm Rouhan Qian from Baidu Mechanism Design team. And I talk about reinforcement multi-unit mechanism design. In this talk, I'll first give a brief introduction to mechanism design. And then we'll talk about Baidu's search ads auction and how we migrate from GSP auction to VZG auction. And finally, we'll talk about automatic mechanism design. Mechanism design is really a reverse game theory, and it starts with desired outcomes, and the designer is trying to find the game structure that will generate the outcomes. And the auction is an application of mechanism design, and it has many very successful applications. And we all heard about like spectrum auctions, land auctions, antique auctions. So an auction tries to sell items to potential buyers with unknown values. And it allocates resources to those who can use the items most. And most search engines use auctions to sell ad slots. And Baidu is one of them. It's the biggest Chinese search engine. And we have millions of keywords for sale, and nearly a million advertisers bidding for those keywords. And then the platform in Baidu responsible for the search ads platform is called Fengchao, and it generates more than 10 billion US dollars every year. So before we look into the actual auction system used in Baidu, and let's look at a more simpler case. Is single item auction. And in this case, we have only one item for sale. And we want the auction to be incentive compatible. That means bidders are encouraged to bid truthfully. And we also want the auction to maximize efficiency. Here, efficiency means social welfare. That's the bidder item pair, the value of the bidder item pair is maximized. And in 1961, William Vickery gave a very elegant solution to this problem. It's called second price auction. I think many of you may heard about. And the bidders just submit bid, and the item goes simply to bidders who offers the highest bid. And the bidder, the winner, pays the price equal to the second highest bid. So here is an example. Suppose we have 3 bidders. Each has a value 10, 20, and 30. So the bidding strategy for each of the bidder would be bidding truthfully. That's 10, 20, 30. So, and then the item goes to bidder 3, which has the highest bid. And bidder 3 pays 20, which is the second highest bid. So you can check that no bidders can gain any more utility by bidding, otherwise. Yeah. So search ads auction is a little bit more complex than single item auction, because we have multiple ad slots in the search result page. So this means we are selling multiple items in one auction. So how to do it? And even more, we are actually selling displays, but the bidders bid and pay by click. So we have to do the conversion by ourselves. We have to calculate the value per impression. That is bid multiply click-through rate. Yeah, and for simplicity, here we assume click-through rate is a function of slot rank, and it is irrelevant to the bidder. And most search engines use auction mechanism called generalized second price auction for this problem. And the idea is simply run second price auction for multiple times, and each time for one slot. And it starts from the highest slot to the lowest slot. And the assumption behind this is that bidders prefer high slot because it has a higher click-through rate. And for each sub-auction, each auction for one slot, the allocation and the pricing rule are just the same as a single item auction. Okay, so GSP seems to be a very natural generalization to second price auction. But unfortunately, it does not have the desired outcomes as a second price auction. First, the GSP is not incentive compatible. That means bidding are not encouraged to bid truthfully. And here is example to show why. Suppose we have two slots for sale, and the first slot has a click-through rate of 0.3, and then the second slot has a click-through rate of 0.2. And the two bidders already placed their bid. Each placed 10 and 20. So for the third bidder, the value of the bidder is 30. So what's the optimal bidding strategy for the third bid? So if the bidder bid 30, which is the true value, and he will get slot 1, and the payment would be 20, which is the second highest bid. So the utility for him would be 30 minus 20 and multiply 0.3, which is 3. But if bidder 3 lower his bid to, say, 15, he will only get slot 2, which has a lower click-through rate. But the payment would be also less, which is 10. So the utility for him would be 30 minus 10 and multiply 0.2, which is 4. So it seems that bidder 3 can have a higher utility by bidding less than the true value. And that means GSP is not incentive compatible. And to make things worse, the bidding strategy, the optimal bidding strategy for the bidders is unknown and is very complex. And so we observe that in our system, advertisers just constantly changing their biddings, and it costs a lot for the advertisers. And the second problem with GSP is that it does not maximize social welfare. So we are not making the most use of the ad slots. And there are many reasons, and two of them are here. First, as we said, it's not incentive compatible, and we do not know the bidding strategy. So it's impossible, since we do not know the value, it's impossible for us to allocate it efficiently. And the second, GSP just assumes that the click-through rate is decreasing. But we did experiments, and the results show that actually more than 10% of ads has higher click-through rate in lower slots. And maybe it's a result of ad blindness or something, but we don't know the reason, but it's a fact. So is there any better auction for search ads problem? And actually there is one, and is VZG auction. It is incentive compatible, and it can maximize the social welfare in multi-items auction scenario. And it is designed like this. First, we just assume that bidders are bidding truthfully. And then we, based on that assumption, we do allocation. And then we find a pricing rule to make the auction incentive compatible. So the allocation would be simple, because we are assuming that bidders review their true value. So we just iterate over all the possible combinations of display and find out the particular combination that would maximize the overall social welfare of the whole page. And the pricing is the key to make visage incentive compatible. And it can be proved that if we charge each bidder with marginal harm it caused to other bidders, then this auction would be incentive compatible. So it seems to be a perfect solution. But it's interesting that in the industry, most search engines simply use GSP instead of VCG. And there are many literatures explaining why. And I think one of the main reasons is that GSP has been around, it was invented in 2001, and it has been used by most search engines for many years. And the auction system is so fundamental that the cost of just getting a new auction is very high. So the industry just reluctant to do it. And for several reasons. First, developing a new auction requires, of course, a lot of design and engineering work. And as we said, bidders tend to bid untruthfully and actually underbid in GSP. But VCG is truthful. So if we switch to VCG, it requires bidder to raise their bid. And during that time, during that period, VCG might be inefficient because the bid are not truthful. And the third reason here is the expected price for VCG is lower than GSP for the same bidding factor. So this makes VCG generate less revenue, at least for a short time for the company. So for most joint search engines are public listed companies, and for them it is very risky to have a revenue loss even in short term. But in recent years and in Baidu, we also see some opportunities for VCG to beat GSP, and because VCG views the auction as a page, and it does not assume a decrease in click-through rate. So the efficiency may be improved. And also, we have developed a better click-through rate prediction model. And if we use VCG, the contextual features can be used to improve the CTR model accuracy. And finally, and most importantly, we have observed a rising popularity of dynamic sizing, and this means ads with different sizes are competing together. And the VCG cannot handle this problem, so there is a loss of efficiency as well as revenue in VCG. But GSP can handle it by nature. So this provides us really an opportunity to make things right. And in 2018, we designed a VCG auction in Baidu. And here is a very high-level structure of auction, and without many details. First, we have a candidate ads list, and we generate the ad style pairs because of the dynamic sizing problem. And then we generate the possible display combinations of all the ad style pairs. And then we use CTR model to make the prediction and calculate the social welfare of the whole page and do the allocation and the pricing. Yeah. So the result is quite satisfying and actually surprised us. First, unlike most literature believe that VCG can hurt revenue in short term. But the result, our result shows that both efficiency and the revenue have a very significant rise, even in short term in A/B test. And what's more, we observe that bidders are raising their bid after we deploy the VZG auction. And this is because in GSP, bidders are underbid, and in VZG, bidders are encouraged to bid truthfully. So, and actually, after we deployed the VZG, and in 2 months, bidders raised their bid for almost 20%. That's a very significant rise, and it's for advertisers, they are just have less work to do for bidding. Okay, so we talk about GSP and VZG in theory, but the real-world auction is much more complex, and we have many strategies bonding together, and it is a multi-target problem. We care about the efficiency, revenue, user experience, computing efficiency, and so on. So it is a great challenge for us to manually develop an optimal auction. So inspired by auto machine learning, we try to develop an automatic auction system that make the machine to do some of the work for us. And first, we model the auction as a parametric mechanism class, and there are some hyperparameters that can be tuned. And we use deep reinforcement learning network to search for a better auction. And here is the structure. And we model the auction mechanism as a sequence of steps. And in each step, there is a hyperparameter that can be tuned. So it is just like a string. We can use a recurrent neural network to model the string. And so in each step, we use the output from last step as input. And the network try to maximize the expected reward of the new generated auction. So, okay, so we develop a reinforcement learning framework to train the LSTM network, and in particular, we build an auction simulator, which takes the parameter vector and the sampled auction data as input, and it just simulates the auction process online, and it produces reward, and we use the reward to train and we use the reward to do gradient descent to train the LSTM network. And we have an evaluation model, and if the new generated auction is good, we put it online. So reward can be anything. Is a function of the expected outcome. Okay, so there are several applications of this already deployed. We use it to use the automatic auction design to improve ads quality, and also we used it to do dynamic style pruning, and also we are working on more applications and also improving the model itself. Okay, thank you. If people don't understand the mechanism. Well, actually, most advertisers do not understand the mechanism. Yeah, yeah. They just, but they understand their utility. That's enough. So they just submit a bid, and then they get a reward. And so they just change the bid and make some choice, and if the reward is good, they just did. So that's why we want the auction to be incentive compatible. And so the work for the advertisers will be minimized, and they just review true value. Yeah. And we don't expect them to understand the mechanism. Yeah. Uh, yeah. It can be a function that it can be any function that the seller cares about. Maybe for Baidu we care about the revenue, of course. Yeah, we care about the efficiency. Efficiency means the overall value that these ad slots will generate. Yeah, and we care about the user experience, and also computing complexity is considered. Yeah, but you can define any functions. It's not limited to this. Yeah.
I have one here.
Yeah.
Isn't there a risk if you change your bidding system that and your competitors don't,
Uh-huh.
that advertisers will worry about the difference? Isn't there first mover disadvantage here?
Yeah, yeah, and I think that's why most companies, just use GSP because GSP is so popular. but actually, uh, Baidu is the dominant search engine in China, and actually the bidders, and we just did some customer survey after we did some experiments, and then the customer do not have any feeling of it because they don't care about the mechanism, they just care about the results. Yeah. Yeah. No, it's online, and cause we have a data pipeline from online, and the distribution of data are changing, so we update it constantly. Yeah.
So, let's thank Jeff again.
Yeah. Thank you.